Okay, happy Tuesday. Okay, we have lesson 5 of unit 5 is graphs of functions part 2. So you have a power up that you're going to have to move this vertical line to whatever number it says to move it to. Then answer what is your y value. Remember, y's are over here, x's are over here, for both when x is 2 on the A line and when x is 2 on the B line. Then the other power up question, you're just telling me what you notice and what you wonder. Activity 1. We have these graphs about time and temperature, but because temperature is such normally a wide range sometimes, we don't have data for certain temperatures. So we don't have huge graphs that take up way too much space. They put these little 2 lines, that means they skip data. Sometimes you can also, it could be a zigzag line. And all that means is there are more numbers, but we're just not using any. Okay, so this is from the temperature between noon, so at 0, that's actually noon, 12 p.m., until midnight. We have temperatures for a certain city. They don't tell us which city this one is. Okay, which does the graph show? Temperature of a function of time or time as a function of temperature? Well, what they're really asking is which one is dependent on the other. So remember, our x, our input, is always independent, and our y, our output, is always dependent. So our temperature is dependent on the time of the day. So temperature is a function of time. So what is the approximately the temperature the highest? When? So we need to look at the time. Well, our highest is all the way up here. And it's not quite 6 p.m., so we could say like 5:45. And then it already has p.m. because all these are afternoon times. Okay, activity 1 again, same graph. Which is warmer, at 3 p.m. or at 9 p.m.? So when we look at these, we have to look at the times. So I have 3 p.m. over here. I go up. There's my temperature for 3 p.m. And there's my temperature for 9 p.m. Well, which one is actually higher? Okay, well, the 9 p.m. So determine another time where the temperature was the same as 4 p.m. So we find the temperature of 4 p.m. And you pretty much can just go all the way across and find the other time, which is 8 p.m. So put in your 00. And what is that temperature? Well, that is at the 57 degrees. Okay, when is the output? When is the input 10? What is the output? So remember, 10 input is hours. And what is our output? Well, what's the temperature at 55 degrees? Or you just put in 55. What does that tell you about the time and the temperature? Well, that tells me at 10 p.m., the temperature is 55 degrees. You're just basically restating what the graph is showing for that ordered pair. Alrighty. Activity 2. Go ahead. I want everyone to go ahead and select San Francisco, because otherwise our data is different for each of these because they all come from different areas, so they have different temperatures. And so it's easier if we all just use the same city. All right, now these graphs are not very friendly-ish. Like we go up by 2.5 degrees. So some of these, if you don't have it exact, is going to be off. So that's why I want to make sure we're using the same cities. Okay, our highest. Well, our highest is all the way up here. Well, this is 75. And they go up by 2.5. This is 77.5, right? Well, it's not quite at that. So we could assume then that's going to be 77 degrees. And then what's our time? You should be able to figure out the time. It's so much easier. Okay. What is the low temperature? So we find our lowest point, which is all the way down here. Okay. So that one has to be definitely less than 50, but more than 45. So we're going to go with 47 degrees is what they have in the book. Okay. So 47 degrees. Because it's not quite at the 47 and a half. It's just below it. Then figure out what time is that. You can just put the hours. So you don't have to try to figure out like after 12 hours, is that 1, 2, 3? Just put how many hours. Okay, with that information, oops, let me get rid of my dots. When are we increasing? So increasing is a positive slope. So here is our increase. So that's between these times right here. So that's between the hours 6 to 14. 6 to 14 hours. And then when are we decreasing? Well, that is a negative slope. So from our 14, we kind of have a little decrease and then another increase, but let's just focus on those. So from 14 to 20. 20 hours. Okay. All right. Slide 8. Within your group, use your responses from the previous slides to take turns reporting the weather. Okay, so when do you think we're going to have our highest temperature? What time of the day? Do you think we'll keep staying with a warm temperature? Kind of like, what is the data you could get from this? So your answers might vary. So here's our summary of basically a lot of today's. It's important to know which way is increasing and decreasing because you're going to have to actually draw a graph now for one of your practice problems. Okay, so your practice problems are problems 1 through 4. Okay, you must do both parts or it's going to count it wrong. Okay, this says days. There are multiple correct answers. So you have to select all of them or it's going to mark it wrong. Then using this one, select which one it is. Explain your thinking. How do you know from which one's independent, dependent? Now this one, a lot of kids were missing earlier today. This is your starting point. So this is actually your tower. And then you have the ball that's being thrown. Okay, so that'll help you answer this question. And then don't forget you also have to drag the dot. And then when are we, the one time interval where the height of the object is increasing, and then where are we decreasing? How many seconds? Oops. Problem 3 is a kind of the more struggling one. You have to find your information and then put it into your equation. So you might have to do a screenshot and take the information and put it in. And like screenshot and draw if you want, or do it on paper. So we have 2.5 hours traveling at 35 miles per hour. So our 35. So that means I'm going to replace my y with 2.5 and solve for x. So you need to find out what x equals. Then if the car spends no time traveling, how fast would it take the trip? So no time is a 0. So you basically have 55x equals 200 for that one. Okay. So then you would find again what is x equal. Then your last problem, you're going to start with your ordered pair, show when it's decreasing, and then when it increases. And then once you're done, make sure you work on missing work. Make sure you finished yesterday's work so that you have all that put in. Alrighty? Have a good day, and I will see you tomorrow.